This will be the last video in Unit 4, at least that's my intention. This is on quadratic inequalities. This can be quite challenging for some students, so pay careful attention and take really good notes. Okay, so to graph a quadratic inequality, basically we're doing the same thing that we did with linear inequalities. We're taking into consideration whether it's greater than or equal to, so that you would have a dotted or solid line. And then the other thing we're doing is we're just going to graph this quadratic equation, and then we're going to do shading. So it's just like what we did with the linear, except we're going to graph the parabola. And this parabola, this quadratic inequality, is written in standard form. So we could plot some points, or we could find the vertex, and we know that A is 1, so it would not have a stretch or shrink. So I'm going to, real quickly, I'm going to do negative B over 2A, and that's going to get me positive 3 over 2, and that will be my vertex, and then the x-coordinate of the vertex. And then I also know that it has a y-intercept at 0, 2, because of the standard form of that equation. If I factor this, I would have x, 2, 1, minus, minus. So I have zeros at 2 and 1, right? And then I also know that the vertex is at 3/2 something. And then I also know this is here. So it's probably, I don't know, somewhere, but it's going to be negative. So I have 9/4 minus 9/2 plus 2. And so this would be negative 9 over 4 plus 8 over 4. So this will be negative 1/4. So somewhere in here. Okay. So that's going to be my parabola. And then I know it's going to be a dotted, or it says here slashed line. I'll try to do that. It's hard to do that on my iPad. Okay. All right, and then I pick a test point. Now, it says pick a test point of 1, 2, but my favorite test point is 0, 0, right? So if I put a 0 in for x, I'm going to get, and put a 0 here, I'm going to get 0 is greater than 2. Is that true? No. So I'm going to shade where 0, 0 is not, which would be the inside. Okay, so it says here, which is the graph of y is less than negative x squared plus 4x plus 2, and they already have it graphed for you. So we know we can eliminate a couple of these because this is less than but not equal to. So we know it's going to be either C or D. And so the other thing that we have to know is it on the inside or the out? So I'm going to pick a test point, which is my ultimate favorite test point, 0, 0. So I'll have 0 plus 0 plus 2. Is 0 less than 2? Yes. So it's going to include the inside, and so it's D. So basically that's it. If I want to graph something that looks like y is less than, or y is greater than, or y is less than or equal to a quadratic, then that's the method. You graph the parabola, you do a test point to see whether you shade the inside of it or the outside of it. Okay? So in the next part of the video, we're going to talk about graphing an inequality that looks a little bit different. Okay, so the ones we've done before look like these over here on the right, where we had y is equal to ax squared plus bx plus c. That's not an inequality. So then if we did this, we would graph it and we would shade either between or around, right? Or something like this, same thing, right? So that's what we did previously. Now, look at the difference here. What we have here is a y. Over here, we have 0. So if we were doing something like this, we would actually be finding where the graph is on the x-axis. So this would be on the x-axis. We would be finding the x-intercepts, right? So if we were trying to find what part of the graph was greater than 0, we would be saying, where is the graph above the x-axis? So this would be above. And then if I had the same quadratic less than 0, this would be the part of the graph that was below the x-axis. Okay? So if I were wanting to graph x squared minus 4 is greater than 0, right? Then I know that this is the graph of x squared translated down 4, right, over 1, up 1. And so it would look something like this. Okay? So the part of that graph that is on the x-axis would be these 2 points right here. These would be the roots. There'd be one at 2 and one at -2, because if you factor that, that's what the factors would be. Okay? In fact, let's do that. So the factors would be x plus 2, x minus 2, and we're seeing where that is greater than 0. Okay? All right, so if it were equal to 0, that would be these 2 points right here. Greater than 0 are going to be these blue pieces right here. Well, where do those occur? Well, they occur from -infinity to -2. And again from 2 to positive infinity. So the answer to this would be 2, what do you call them? Intervals, right? So you have -infinity to -2. It doesn't include -2. And then that's a U for union. That would go from 2 to infinity. And so that would be the part of the x that is above the x-axis. Okay? So another color, this would be, where is x squared minus 4 less than 0? Well, that would be below the x-axis. Okay, and then that would be this piece right here, just the part of the graph that's below. Well, what is that between? That's between -2 and 2. Okay, so depending on, notice it ends in 0, it's greater than or less than, and then you write the intervals to determine where those solutions would occur. So it's not about shading, and it's not about graphing and dotted lines and things like that. It's actually trying to tell you where it is above the x-axis and below. So we can do this same thing algebraically, or using a number line, and let me show you. So the first thing you want to do is you want to solve the related quadratic equation. We've got x squared plus x is less than or equal to 2. So they just took off the greater than or less than, and we're just going to solve it. So we're going to do x squared plus x minus 2 equals 0. Now to solve it, remember we factor. We have x, 2, and 1, and I notice that 2x, right? I'm looking at that. That's going to need to be positive. So this is positive, that's negative. So my zeros are going to be 1 and -2. All right? So let's make a number line, right? And here is -2, and here is 1. And it said less than or equal to. So I'm going to make those included. And I'm going to pick a point in each test interval. So over here, this is a test interval. I'm going to pick -3. Here I'm going to pick 0, and here I'll pick 2. And I'm just picking them. They're in the interval. Okay? So I'm going to plug in a -3 and see if it's true. Right? So I've got -3 squared plus a -3, and I'm going to see if that is less than or equal to 2. So I have 9 plus a -3, which is -6. It is not. So this is no, not in that interval. All right, so I'm going to pick 2. I'll go jump over here and pick 2. So I have 2 squared plus 2 less than or equal to 2. Right? So 4 plus 2 is 6. 6 is not less than or equal to 2. So this interval is no. So most likely this middle interval will be true. Okay? So let's see. So if I put a 0 in, is 0 less than or equal to 2? Yes. So this would be your interval. So the answer to this question will be -2 to 1. Okay, so one last example. notice this is 0. We're going to solve x squared minus 4x plus 3 by graphing. Okay, so I am going to try to factor first, and I have x and x, 3 and 1, negative and negative. Okay, so I'm going to find the zeros are at 3 and 1, so here's 1 and here's 3, and it's going to go up like this. All right, so because it says less than, I want to know where it is below the x-axis. Okay, and so I'm going to look at my intervals. So it's going to go from here to here. Oh, sorry, no, below would be between my zeros. So this is going to be between 1 and 3. Always go smaller to larger, and that's the answer. Okay, so this was a lot of information, but I will see you in class, and we'll go over this again, probably do some up on the boards.